It's understandable to avoid paperwork and the hassle of owning a business, but there are potential disadvantages to not doing so. Firstly, limited earning potential. As an employee, income will be capped by employer policies and may not reflect full potential. Secondly, lack of control. One will not have control over a work schedule, benefits, or other aspects of employment. Thirdly, missed opportunities. Running a business can provide opportunities for growth, diversification, and innovation. There is no special classification of electrician licensing in Philadelphia that restricts the amount of work that can be performed or reduces insurance coverage. However, it is important to note that all electrical work in Philadelphia must be performed by a licensed electrician. The Philadelphia Department of Licenses and Inspections (L&I) does not specify a gross sales limit for electricians. However, the insurance carrier may have its own requirements for annual gross sales audits. It is recommended to check with the carrier to confirm the specific requirements. While $3,000 per year may be a modest income for an electrician, it is still important to report all earnings to the insurance carrier. Failure to do so could void the insurance coverage and leave one financially liable for any accidents or incident. The $2 million coverage is adequate for most electrical work. However, it is important to review the policy carefully to ensure that it meets specific needs. One may also want to consider adding additional coverage, such as workers' compensation insurance, if planning to hire employees in the future. Based on the information provided, it is unlikely that one will encounter any issues with an electrician's license or insurance coverage. However, if there are plans to expand a business in the future, it is advisable to consider forming a business entity to protect personal assets and increase earning potential. Understanding the National Electric Code or NEC is essential for electricians. The NEC is a comprehensive set of standards and guidelines for safe electrical installations. Regular updates occur, so staying current is critical. Some key articles and sections of the NEC to be aware of. Firstly, Article 90 introduces the NEC purpose, scope, and enforcement. Secondly, Chapter 1 covers general requirements like definitions, wiring methods, and calculations. Thirdly, Chapter 2 focuses on wiring and protection, including overcurrent protection, grounding, and bonding. Fourthly, Chapter 3 covers wiring methods and materials such as conduit, cables, and raceways. Fifthly, Chapter 4 addresses equipment for general use, including receptacles, switches, and luminaires. Sixthly, Chapter 5 pertains to special occupancies, like hazardous locations and healthcare facilities. Seventhly, Chapter 6 covers special equipment, such as electric signs and elevators. Eighthly, Chapter 7 addresses special conditions like emergency systems and fire alarm systems. Ninthly, Chapter 8 focuses on communications systems like telephone and data. Lastly, Chapter 9 provides tables and examples for calculations. Key concepts within the NEC include firstly, grounding and bonding, which ensure a safe path for fault current to return to the source, minimizing the risk of electric shock. Secondly, overcurrent protection, which involves using circuit breakers and fuses to protect circuits from overloads and short circuits. Thirdly, conductor sizing, which ensures that conductors are appropriately sized for the amount of current they will carry, preventing overheating and fires. Fourthly, wiring methods, which dictate how conductors are installed and protected, considering factors like environment and mechanical stress. Fifthly, arc flash protection, which aims to mitigate the hazards associated with arc flash events, protecting workers from severe burns and injuries. Specific tables in the NEC that are frequently used include firstly, Table 310.15b16, which provides opacity ratings for conductors based on insulation type and ambient temperature. Secondly, Table 250.122, which specifies the minimum size of equipment grounding conductors. Thirdly, Table 430.250, which provides full load current values for three-phase alternating current motors. Fourthly, Table 430.251a, which provides full load current values for single-phase alternating current motors. Fifthly, Table 310.16, which provides allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 conductors in raceway or cable or earth, based on ambient temperature of 30 degrees Celsius. Sixthly, Table 250.66, which provides grounding electrode conductor size for alternating current systems. Seventhly, Table 314.16a, which provides box fill calculations for outlet and device boxes. It is important to perform load calculations to determine the appropriate size of electrical services and feeders. This involves calculating the total connected load and applying demand factors as permitted by the NEC. Voltage drop calculations are also important to ensure that voltage at the point of utilization is within acceptable limits. The NEC provides formulas and guidelines for performing these calculations. When working with electrical systems, personal protective equipment, or PPE, is essential. This includes items like safety glasses, gloves, and arc-rated clothing. Lockout-tagout procedures should always be followed when working on energized equipment to prevent accidental energization. Safe work practices also include maintaining a safe distance from energized equipment and using insulated tools. It is important to understand the different types of electrical drawings and diagrams. Single-line diagrams provide a simplified representation of an electrical system, showing major components and their interconnections. Wiring diagrams show the detailed connections between components. Panel schedules provide information about the circuits in an electrical panel, including the breaker size and the loads served. Understanding these drawings and diagrams is essential for troubleshooting and maintaining electrical systems. When troubleshooting electrical circuits, it is important to use appropriate test equipment, such as multimeters, clamp-on ammeters, and voltage testers. Always verify that the equipment is properly calibrated and in good working condition. Follow safe work practices when using test equipment, such as wearing appropriate PPE and avoiding contact with energized parts. Start by visually inspecting the circuit for any obvious problems, such as loose connections or damaged components. Then use test equipment to measure voltage, current, and resistance to identify the fault. Always follow a systematic approach to troubleshooting, starting with the most likely causes and working your way through the possible causes. Effective communication with clients is also important. Clearly explain the scope of work, including the tasks to be performed and the estimated cost. Provide regular updates on the progress of the work. Answer client questions and concerns promptly and professionally. Document all work performed, including the materials used and the results of any tests or inspections. This documentation can be helpful for future maintenance and troubleshooting. Also, stay updated with continuing education. Electrical technology is constantly evolving, so it is important to stay updated with the latest advancements and changes to the NEC. Attend continuing education courses and seminars to learn about new technologies and best practices. Read industry publications and participate in online forums to stay informed. Continuing education helps maintain competency and provide the best possible service to clients. Different types of electrical systems exist. Firstly, residential electrical systems are typically single-phase, 120 volts or 240 volts, and serve lighting, receptacles, and appliances. Secondly, commercial electrical systems may be single-phase or three-phase and can operate at voltages such as 120 volts, 208 volts, 277 volts, or 480 volts, serving a wider range of loads, including HVAC systems, motors, and lighting. Thirdly, industrial electrical systems are often three-phase and operate at higher voltages, such as 480 volts or higher, serving heavy machinery, manufacturing equipment, and large-scale processes. Each type of system has its own unique requirements and considerations. Understanding motor control is essential for electricians. Motor starters are used to safely start and stop motors, providing overload protection and other features. Variable frequency drives, or VFDs, are used to control the speed of motors, improving efficiency and reducing energy consumption. Programmable logic controllers, or PLCs, are used to automate motor control systems, providing precise control and monitoring of motor operation. Understanding these components and systems is essential for working with motors in commercial and industrial settings. Grounding and bonding are critical for electrical safety. Grounding provides a low impedance path for fault current to return to the source, minimizing the risk of electric shock. Bonding ensures that all metal parts of an electrical system are electrically connected, preventing voltage differences that could create a shock hazard. The NEC provides detailed requirements for grounding and bonding, which must be followed carefully to ensure safety. Understanding different types of raceways and conduits. Firstly, rigid metal conduit, or RMC, is a heavy-walled conduit that provides excellent mechanical protection and is suitable for use in harsh environments. Secondly, electrical metallic tubing, or INT, is a thin-walled conduit that is lighter and easier to install than RMC, but provides less mechanical protection. Thirdly, flexible metal conduit, or FMC, is a flexible conduit that can be used in tight spaces or where movement is required. Fourthly, liquid-tight flexible metal conduit, or LFMC, is a flexible conduit that is liquid-tight and suitable for use in wet locations. Selecting the appropriate type of raceway or conduit depends on the specific application and environmental conditions. Overcurrent protection devices are critical for protecting electrical circuits from overloads and short circuits. Circuit breakers are reusable devices that trip when an overcurrent condition is detected, interrupting the flow of current. Fuses are one-time use devices that melt and open the circuit when an overcurrent condition is detected. Selecting the appropriate overcurrent protection device depends on the circuit's ampacity and the type of load being served. Lighting is an important aspect of electrical systems. Incandescent lighting is an older technology that is less efficient than other options. Fluorescent lighting is more efficient than incandescent lighting and is commonly used in commercial and industrial settings. Light-emitting diode, or LED, lighting is the most efficient type of lighting and is becoming increasingly popular due to its long lifespan and lower energy consumption. Selecting the appropriate type of lighting depends on the application, energy efficiency requirements, and desired light quality. Performing electrical calculations is essential for designing and installing electrical systems. Ohm's law states that voltage equals current times resistance, and is used to calculate voltage, current, or resistance in a circuit. Watt's law states that power equals voltage times current, and is used to calculate power in a circuit. The NEC provides guidelines for performing load calculations to determine the appropriate size of electrical services and feeders. Voltage drop calculations are also important to ensure that voltage at the point of utilization is within acceptable limits. Consider energy efficiency when designing and installing electrical systems. Use energy-efficient lighting, such as LED, to reduce energy consumption. Install occupancy sensors to automatically turn off lights in unoccupied areas. Use energy-efficient appliances and equipment. Implement power factor correction to improve the efficiency of electrical systems. Designing for energy efficiency can save money on energy bills and reduce environmental impact. Smart home technology is becoming increasingly popular. Smart thermostats can be used to control heating and cooling systems remotely and optimize energy consumption. Smart lighting systems can be controlled remotely and can be programmed to automatically adjust based on occupancy or time of day. Smart security systems can provide remote monitoring and control of security devices. Installing smart home technology can enhance convenience, security, and energy efficiency. Consider renewable energy sources when designing electrical systems. Solar photovoltaic, or PV, systems can generate electricity from sunlight. Wind turbines can generate electricity from wind. These renewable energy sources can reduce reliance on fossil fuels and lower energy costs. Installing renewable energy systems requires specialized knowledge and expertise. Electrical safety is always the top priority. Always follow safe work practices and wear appropriate personal protective equipment, or PPE. To energize circuits before working on them. Use lockout-tagout procedures to prevent accidental energization. Inspect tools and equipment regularly to ensure they are in good working condition. Never work on electrical systems when tired or under the influence of drugs or alcohol. Stay up to date with the NEC and other relevant safety standards. It's also important to know about arc flash hazards. Arc flash is a dangerous phenomenon that can occur when electrical equipment fails, creating a high-energy explosion of heat and light. Arc flash can cause severe burns, injuries, and even death. The NEC requires that electrical equipment be labeled with arc flash hazard warnings. Employers must provide arc flash training to employees who work on or near energized equipment. Arc flash personal protective equipment, or PPE, is essential for protecting workers from arc flash hazards. Remember to follow lockout-tagout procedures. Lockout-tagout is a safety procedure used to prevent accidental energization of equipment during maintenance or repair. The procedure involves isolating the equipment from its energy source and attaching a lock and tag to the energy isolating device. The lock and tag prevent anyone from accidentally energizing the equipment while it is being worked on. Lockout-tagout procedures must be followed whenever working on energized electrical equipment. It is important to know about electrical codes and standards. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The NEC provides comprehensive standards for safe electrical installations. State and local jurisdictions may also have their own electrical codes and standards. It is important to be familiar with the applicable codes and standards in your area. Consider the environmental factors when designing and installing electrical systems. Wet locations require the use of waterproof equipment and wiring methods. Corrosive environments require the use of corrosion-resistant materials. Hazardous locations require the use of explosion-proof equipment and wiring methods. Environmental factors must be considered to ensure the safety and reliability of electrical systems. Also consider the Americans with Disabilities Act or ADA requirements. The ADA requires that electrical systems be accessible to people with disabilities. This includes requirements for the height and location of switches, receptacles, and other electrical components. The electrical systems must be designed and installed to comply with ADA requirements. Perform regular maintenance on electrical systems. Inspect electrical equipment for signs of damage or wear. Test circuit breakers and other overcurrent protection devices. Tighten connections and clean electrical panels. Regular maintenance can prevent electrical problems and extend the life of electrical systems. Document all electrical work. Keep accurate records of all electrical work performed, including drawings, specifications, and test results. This documentation can be helpful for future maintenance and troubleshooting. It can also be used to demonstrate compliance with electrical codes and standards. Finally, stay informed about new technologies. Electrical technology is constantly evolving. Stay informed about new products, materials, and installation methods. Attend industry trade shows and conferences. Read industry publications and participate in online forums. Staying informed about new technologies can help improve efficiency and provide better service to clients.